What's up, team? How we doing? AP Stats. This is Coach Jay in the house. We got Mickey in the house. Hey, I hope you're having a fantastic night. There's nothing better. I mean, right now I am chilling on my couch with Kiki. I've got my Crazy Love mug and had coffee. This is awesome. This is one of my favorite times. It's kind of crazy. One of my favorite times right here. If you like this music, Lunar Vacation. I got turned on to it by, was it Annie Kilpatrick? I think. But yeah, check it out. It's good stuff. Hey, I want to get to a lot of your questions. I'm going to tune down the music here. I see that we have a lot of viewers already, some that are probably coming in late. We started pretty close to being on time, but I know that we have still stuff to go through. And so what I'd like to do is just kind of go over a couple things. First off, I think there's two major things that we could kind of address and kind of go over. We went through a lot of stuff today in class. The first of which is if you have any topics, any of the 16 topics that I put on the for the chapter 1, if that's you, then man, just throw out that topic. Hey, I got a question on this topic, which is directly to the right side of me. So if you get a chance to throw that down on the list, I'll address that, go over it, go through it, and then we'll go from there. If you have also questions from the review, if there's things that you need help with, please make sure of it, and we'll go over that together. The only other thing that I would say is that as I look at homework that was due today, continue to put context in. Some people are still forgetting context, and it's very, very important to your success, especially on the test tomorrow. Also, if you have any other questions, just basic on like tests and what you think you should do, or just any questions along those lines, let me know. We're going to try to hit this for about 45 minutes, and then if it's still kind of heavy, we'll keep it rolling. Any questions that I didn't answer, feel free to come in tomorrow at 7:30, get those answered as well. And then we're going to take the test pretty close to right away, so we'll get it and we'll rock and roll from there. Cool. Cool. So with that being said, let's do this here. We're gonna turn off the music, and we're going to share my screen here, and hopefully this will work along. If this is not working, please let me know. Sometimes there have been moments where this has not worked, and as I say that, my screen share is messing up. So hold on just a sec. Let me see if I can. Yeah, hopefully this will. Sorry, y'all. And wow, come on. Something's up here. Let me see if I can get this. I thought we were rocking. This is not. Let me see if I can. See if I can do this. You're not going to see me for a second. I'm still here. Just trying to make sure. Cameraman, what in the world? What is that? I think there's a button that's not quite working here. Hey, is this working? Oh, there we are. Hey, I hope this is working. As I watch this, it's starting to share now, so I'm good. But really what I wanted to do is just make sure that I'm going to pull this over. Sorry about that, gang. See if this will This is going to work, I know. Okay, perfect. I'm here. I'm good to go there. The only other thing that I wanted to just address to make sure on, if you are going to have if you have technical difficulties at all, please make sure, I want to make sure this link is actually rolling here. Perfect. You can see that there. I'm going to make sure the comment section's working, and we can start with any questions you've got. Yeah, I'm good now. Sorry about that. I see all y'all's comments. Appreciate you. David, I didn't see your computer in my room, my man. Sorry about that. Brianna, what a great idea for a group me. That's actually really solid. I would highly recommend that. All right. Sorry. Yeah, Brianna, I'm sorry. I'm looking at the questions. I am good. Let's address the questions. Let's go. Let's get it rolling. I'm going to start with a blank screen, but if you tell me that you want a specific question off of the review, then rock and roll. But I'm going to give you like 30, like maybe 15 seconds. Just put a topic on the snapshot side, and we'll go through that, all right? Cool. All right, do that real quick. Put a topic there, and I'm just going to start addressing topics there. I'm going to get my notebook right here. Perfect. Glad this is working. Sometimes I've had technical difficulties in the past. I'm glad we're good. All right, perfect. Let's address it. And it says on the review, why is there just – yeah, okay. I think there was a question, Eric. If you saw that, you could skip that. I think the question was number 4, and I think it got skipped or moved to the other side. If you continue on, it got put out of order because I had to scan it in. Eric, do you see that you see a pie chart, right? And it says, which of the following bar graphs is equivalent to the pie chart? It's a categorical measurement on number 4 because obviously it's a pie chart there. And we're talking the categories are the description of the cost of their health insurance. And so based upon that, you're trying to just kind of make sure that, you know, which one would be towards the proper percentage. And so what you're trying to do is just go through A, B, C, and then D and E are on the next page. But my apology, that pie chart was put on a weird page because I scanned it in and I put it on the wrong one there, okay? Does that make sense, Eric? If it does, just give me the thumbs up. If it doesn't, let me know. I know that. Perfect. Number 10, yep, I'm going to do that one. Context again and what and how much of it we need again. Perfect. David, tell you what, I'm going to do one of the review questions. Since I know what was on the test, let me do this. I'm going to address 10 first there, Brianna. But before I do that, I want to look quickly at the FRQs here. Just want to make sure I've got it. Good. Okay, I'm actually going to do, I think I'm going to do number 2. I'm just looking at the differences here, just making sure we're good. And someone remind me to do 4. So I'm going to do 4 is a really good one. 2 and 4 are solid, solid ones there, and we'll go through that. So I'm going to start at 10. I'm going to go to 2, and then if I need to go back to 4, I absolutely can. But let's start with number 10 on this section, and I believe I have it pulled up here. And backtrack. Where are you? Where are you? There you are. Okay. All right, let's go through number 10. I'm going to move Kiki out of the way, and we're going to get this thing rolling. All right, number 10 talks about when testing water for chemical impurities, results are often reported as BDL, that is below detection limit. The following are the measurements of the amount of lead in a series of water samples taken from inner city households, okay? Again, the biggest thing I think with doing multiple choices, sometimes there's a lot of answers that sound right, but in reality, they're not the best answer. So I think that makes it the toughest to prepare for. So as we write this down, we see which of the following statements can we be sure of. Let's look at A. A says the mean lead level in the water is about 10. That's kind of tough because BDL, what does BDL stand for? Below detection limit. So I guess they can't detect it is what I'm thinking. B says the mean lead level in the water is about 9. Okay. The next one says the median lead level in the waters is 7. D says the median lead level is 8, and so on and so forth. Okay. Well, if it's below level, right, you can't detect it, we're just going to represent that as like X, or it's just going to be a low value. So let's put these in order, and what we'll do is we're going to start with BDLs here. We'll go with blue and yellow. That's good. And so what we're going to have here is BDL. There's 2 of them, right? Comma BDL. The next one would be 5, 7, or 5, 6, 7. 5, 6, 7. 8, 10, and 12. 8, 10, 12. And then I think there's even a 20. Now, the reason why I put the BDLs below detection level, we recognize that these are going to be below. We just can't read them. But because we don't know these, we'll just label these as like X, as whatever X would be. There's no way to determine mean because we don't know what these 2 values are. But because these are below detection level, what we can assume is that now we can actually attack these by just finding what the median would be, okay? Because again, if it's below detection level, that means it's going to be definitely lower than this 5 value here, meaning it's to that left side, okay? And so what we're going to do here is we're going to just mark these off as we go. So boom, 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 to where that middle value would be 7. And then I locate this over here and I say, okay, because, again, even though I don't know these values, again, because I don't know, I can't find the mean. But what I can do is at least determine that because it's below detection level, it's going to be the lowest 2 values. Therefore, this is going to be 7. That's why 10 is C, okay? 10 is C. I'm going to make sure that if there's any questions here. Perfect. Okay, I didn't see any more questions there. If you do, just simply put them there, and if you see someone's question there that you know the answer to, respond to that. That's awesome. Okay, but that's how we would do number 10 on that. Okay, sounds good. Let's go to the next one here. My phone's ringing off the hook. I want to make sure I'm good. Oh, that's all. It's all red zone stuff. Perfect. Okay. Next one, I wanted to go to number 2 mainly because of the context that David wanted to address and just kind of what's expected on that. And I think that that's a really good and wise decision there. As we look at this, you'll notice that it says make a stem plot of this data. The biggest thing on this is to make sure that when you do that, that you provide the stem plot in order, if possible. Well, yeah, that's something that's important. Is putting that in order from least to greatest. So what we can do is start with the first, because when we have a stem and then we have a leaf, the leaf can only be one number because you're going to have multiple values in that section. So like, for instance, if I start with 9, we're going to put 6 here, right? And we can actually, let me do a different color. Let's do like green so we can see it in the white too. And then we can just cancel it out. Then we're going to go to 10. And this is where these are the first 2 numbers, right? So we'll start over on this side. So we're going to say 2, 102, comma. Let's see if there's anything else. 6, 9. So 6 and 9. Okay. 6, 9. Good. And it's easier. I probably should have put that 6 here so you could kind of really see the shape that's there, but we're good. So we have 112, 115. So 2, 5. We have a 2, 5, 8. 2, 5, 8. Okay, so we're going to put that there. 2, 5, 8, comma, comma. Let's go to 12 now. On the 12 side, we have 121. So 1, 4, 1 and 4. Wish they'd put these in order for us. That'd probably be nice. 133. So we have that. So we have a 0, 3, 9. And we have a 6 down here. So 0, 3, 6, 9. 0, comma 3, comma 6, comma 9. All right, there. 14 would be, keep going. This can go low, isn't it? And so on and so forth, right? I'm about ready to show you what the graph would look like just so you got it there. I'm going to run out of room. But the big thing that we want to include is that something off to the side that represents something that, like, for instance, 96, just make sure you put something that says 9-6 stands for is equal to 96 in the context, the lengths and minutes of the, so this is 96 minutes of a popular movie. Okay. If you wanted to say that, that's fine. You probably could just say a movie and been okay. But this right here is money. Okay. I actually would count that as context for this problem, but you've got to address where it's at. And I'm going to show you in B what you'll need to do on that as well. But when you do a stem and leaf, you must have a key. That's a part of the process. Okay. All right. So that's A. Did I skip B? I think I might have skipped B. Let me see. Let's look at what B says from this context. And what I'd like to do is just kind of show you what this would look like, right? So this would be what the graph would look like in this context. So you kind of see that it's here. You'll see more of it's skewed right, okay? So this thing is going to be skewed to the right. And part B asks the question, and I'm going to put it right down here before I address C on top. But part B asks this. It asks, the mean of the distribution is 144.7. So I'm going to put that here. Mean is equal to 144.7. Median is 139. Perfect. So as we look at this graph, just a heads up, this thing, when you look at it, you have to look at it coming from this direction. So as if you like flip this over, right? So low to high. So this is going to be a skewed right graph. So if we were to draw this, it would somewhat resemble something like that, right? Okay, you got it there. And what we're saying is that the mean is 144.7, okay? And the median is a little bit lower. It's going to be 139. So this is the median, and here's the mean, okay? So with that picture, pictures are awesome because it allows you to kind of really visualize it. But their question is explain why you could have predicted that the mean would be higher than the median by looking at the stem plot. Well, as we look at this, we can address this. Now, I'm going to pretend like on A, David, that I didn't actually put context here, because sometimes you don't have a stem plot to start it off. Sometimes you go straight into either a question or socks. So to establish context, let's say I didn't do that. What I would say is as follows. I would say, when looking at the stem plot, here we goes context, for the top 25 movie at the stem plot for the top 25 movies and their length, we can see, and this is where I start answering the question, that it is a skewed right graph and will have a higher mean than median because, get my comma in there, whoop, there you are, because mean is not resistant to outliers. And maybe you just put down here where medians are resistant. And maybe you put one more just to kind of give an emphatic yes, get you some to the AP stats people. Maybe you put something else to the effect of, you could say, because it's skewed to the right, it pulls that mean or the average towards it, whereas the median, you can kind of go into more detail about that as well. I didn't even see the answer, so let's see if Coach Jay got it right. It says there are high values at 195 and above. These scores will cause the mean to be higher, but will have no effect on the median. Boom, we had that. Again, being pulled, I probably should address something about outliers. So if I was to be critical of myself, just say something in, where could I put it? We'll have a higher mean skewed right. So we can see that it is skewed right graph. And maybe over here, right here, I say with possible outliers. I mean, that would be good there. If I was doing stocks, I would actually do the outliers, like show it. But that's just me being critical. I explained it, though, why that would be the case. So that's where I would be. As I keep going, I want to make sure I did see a lot more questions here. Going back up. Can we go over context? I hit that right there. And one thing too, David, is if I did hit that, and I do that once, I don't have to do that for A, B, and C. Cool. When in doubt, though, put it down there. But you just need to do it once. Everything is complete sentences, y'all. On an FRQ, everything's complete sentences. Don't list. Please do not list. You will not get full credit for that, okay? All right. Standard deviation when we use it. Yes, absolutely. We're going to go over that. I'll hit that in just a second. Please go over the relationship between mean and mean, like what can conclude about the distribution if one is greater than the other. Hey, Lindsay, did I just address that? I hope I did. I hope that makes sense. So if it's a skewed graph, the mean is pulled by the outliers where the median is resistant or unaffected by that. Lindsay, if you're good, if you could just give me the thumbs up, or Coach, continue to do that just so we're good there. Yeah, Brianna's good. Brianna, you said that perfect. Man, Brianna, you're rocking. Perfect. Yeah, you addressed Lindsay's question. Perfect. Mean like part B on number 1, under other at the end of the study guide. Part B, number 1. Okay, perfect, perfect. I'm going to do this. I'm going to go back. Lindsay, I don't know what just happened right there. You might want to just little grammar check there. Little grammar check. Just messing with you. So let's do part C, and then I'll come back to some of these other questions that are here on this one. Brianna addressed those perfectly. Let's go to C, and I haven't even read this one. The longest movie on the list is 207 minutes, and it's The Seven Samurai. Suppose its place on the list was replaced by Sleep, which is 321 minutes of a man sleeping. Without performing any calculations, indicate whether each of the following measures of center and spread would increase, decrease, or remain the same. And for this one, in complete sentences, I would just restate what they're asking because it's really pretty basic. I would just say, if a 207-minute movie was replaced with a 321-minute movie. Want to make sure we write things out. That's huge too. We could see that. All right, let's address this now. Let's actually put the graph out here. Let's talk about this first. 207 is like the furthest out, isn't it? So we have all this data in the middle. In fact, because we have the graph, let me actually show y'all, okay? So this right here represents the graph, and it would follow the distribution that would be skewed to the right. This is the last value, right? The absolute last value. So as we look at this, we can identify what's changing on this, like which values are changing if we were to exchange the 207 for 317, okay? So if I were, or 321. So let's say 321 was, I mean, that's 32. That's way out here, okay? Way the heck out there. So now we're going to see, does it affect mean? Well, if I were to average all these values out, what would happen if I changed 207 to 321? Well, this thing's going to go way up, isn't it? So we would say that the mean would actually, that would increase, okay? That would increase. Now, what about the median? The median is the middle value, and because 207 was already the last number, 321 would still be the one that would be canceled. So we would say that median would be unaffected. I think that's how you spell that, sorry. Standard deviation, well, this is the tough part, I think. Standard deviation is the average distance from the mean. So think about 207 it already gave us the mean that was, what was it, 144, I think. I think it's 144. I have it here. 144.7, okay? The average distance from the mean is standard deviation. So the distance from 207 minus 144.7 would end up being something along the lines of 62. Is it 62.3? Check me on that, but I think that's right. If we ended up getting the distance from the mean of 321, you would notice that this would end up increasing that distance from the mean. So if we averaged all these distances from 144.7, the fact that we changed 207 to 321 shows us that standard deviation is not resistant to outliers. It's much like the mean, that if we added a value that was larger, that the standard deviation would actually also increase as well. And then also our interquartile range, we understand that the median would pretty much stay the same. What was the median again? It was 139. The IQR of Q3 would be somewhere in here and somewhere in here. The fact that 321 replaces 207 means that it is unaffected. Unaffected. Okay? Now, this brings us to our next point, because what Lindsay brought up was pretty good. When we have median and interquartile range, an outlier really doesn't affect it, okay, especially with only one. So because of that, with median and interquartile range or IQR is for the spread, and you could also put range here, by the way. And then median would also be for, or would be for the center. When it is skewed either right or left, we represent the median here and here. The median is not affected by what's out here, right? So that's why in any skewed situation, we use median and we use IQR, okay? Now, what about if it is approximately normal? Because these are not, mean and standard deviation are not resistant to outliers, right? We understand that it is affected, right? It affects this little spot out here, pulls the mean towards it, right? Pulls the mean towards it. And I use the example of Chris's tackles in a game. If for some reason Chris had a heck of a game and he ends up having 20 more tackles than normal, that would pull his average towards that value, whereas median would be unaffected, okay? Whatever you want to kind of talk about in your context is perfect. So that's why in here you would put mean for center and standard deviation. We're talking about approximately normal. Now, so if I said this, I'd say if a 207-minute movie was replaced with a 321-minute movie, we could see that the mean would increase, the median would be unaffected, the standard deviation would increase, and the IQR would be unaffected. And I would put something again that says median and interquartile range are unaffected by outliers or resistant to outliers, and would be what we would use if it was a skewed or left or skewed right graph, okay? Cool beans. Y'all are rocking. I hope that makes sense. Let's go to some questions. Let's make sure I've got some of those. Got it. Number 8 on the review. I'm going to get to that, Eric. It's a good question. Perfect. Okay. Eric, good. It says, Coach, yeah, my GC, I didn't see any more practice as far as multiple choice questions. I only see, and I'm really struggling with the multiple choice more so than the FRQs. Brianna, if you go to, and by the way, that's a great question. If you go into your textbook, go to your textbook, and at the end of chapter 1, there is, I think there's 10, maybe even more multiple choice. That's like chapter 1 review, multiple choice questions. I would do those. And I know that the odds are in the back of the book. I think all of them are for the test review. But what I would do is go check those out on the backside. I think that would be really beneficial. Again, in your textbook, in chapter 1 review. Eric, that's a really good question. Would we need to talk about the stem plot being bimodal? There was nothing in this context that asked for, now, if it asked for socks, yes, absolutely. That would be really good. But it just said make a stem plot, and then it gave me 2 specific questions. It never told me to address any like describe the graph. If it said that, that would actually be a really good idea to just stop and do that there, okay? Good question, y'all. So we did this one. I think someone said 8, right? Hold up. There was another question up there. I think I got lost on that. Eric, I'm going to do number 8 here in a second. I thought I saw another question up there. Relationship, we did that. I think Emily's question. Standard deviation, when we should use it. I think I already did that, Emily. If you're good on that, please let me know. Make sure that we're good there. So we got there. Perfect. Okay, let's go to 8 and then 1C, I think. Okay, we need to do this one. Let's do 8 first, and then I'll come to that one. I forgot who was first, but we'll do this one first. It says, according to the U.S. Bureau of Labor Statistics, the monthly percentage change in the number of jobs in a certain 12-month had a mean of, sorry, let me backtrack. Mean of 0.08%, standard deviation of 1.7%. From this information, we can conclude the following. Now, the biggest thing that we want to make sure of is we can start eliminating. The A says the largest monthly change was 1.78%. Well, the average distance from the mean is 0.08, right? The average distance from the mean was 1.7. That doesn't mean that the largest one was 1.78. That's the average distance from the mean, right? So that's not true, okay? By definition, that's not true. B says the distribution of monthly changes is strongly skewed to the right. We don't have enough information. Now, if I was given the median to compare to the mean, we could then make an analysis on that, but we don't know. So we only have mean and standard deviation. C says most of the monthly changes were negative. Again, I have no earthly idea. It doesn't tell me that. All it does is just share with me that the average distance from the mean was 1.7. With 0.08 being the mean. D says the magnitude of the monthly deviations from the mean change averaged about 1.7. Well, look at this. As I look at this here, isn't that the definition of standard deviation? It's the average. Now they put it in context, but the mean change averaged about 1.7%. That's why the answer is D, is because really that's the definition of standard deviation. And that's how we go from there. And by the way, this is not true, because the standard deviation can be bigger than the mean, 100%. So don't freak out about that, especially if you don't know the values. They're just trying to trick you, okay? It's trying to trick you there. You know the stuff for tomorrow. The big thing is don't second guess yourself. If you think it's the answer, go with it, and then rock and move forward, okay? Great questions, y'all. Great questions. Let me keep going down. Brianna, how do I know it's bimodal? And I'm going to go to number 1C for Lindsay here. If you notice, as we looked at this graph here, you'll notice it kind of comes up, hits, dips down, and then comes back up. I would categorize that as bimodal. It's fine if I said it. Yeah, I would say that would be a bimodal graph there. Okay, C says the histogram suggests that there may be an outlier, possibly out here. Use the 1.5 IQR rule of thumb to show that no values in the distribution meet this criterion for outliers. Now I'm assuming that up here, number 1, you've already said context. So if that's the case, we can just simply show our formula. So low value is less than, and this is our range here, right? And high value would be greater than Q3 plus 1.5 times IQR. That's a very, very important formula, y'all. Very important. Got to know that one. And then minus 1.5 times IQR is over here, okay? Now, the IQR could be taken from this little mini tab here. And by the way, just a heads up, throw that value out. I've never seen it used. And I don't even know what it is, to be honest. It's standard error of the mean. We never got to that. We just don't use it, but they try to confuse you. It's just a heads up there. But the Q1 would be 2.23 minus 1.5 times IQR, which would be Q3 minus Q1, which would end up being 4, is that 39.4. So what we want to do is just simply show that that this, in fact, that the 41.63 plus 1.5 times 39.4, that these values of the range, the low value and the high value, that if all of our values that are here fall in this range, then we have no outliers. But if something falls either lower than the low value or higher than the high value, we denote that with a we'd say that that would be an outlier, and we would put that in. And really, the one they're worried about is this one here. And let me put that in my calculator real quick. See if I've got it here. I think I threw it. I think I threw my phone early. Oh, here it is. So as I look at it, and you just kind of explain that, throw that down there and say, because all values fell between our low and high value within our outlier formulas, we conclude that there are no outliers within this data. And that would be sufficient. Something quick. No context needed. If you've already stated it, don't worry about it, but it needs to be put somewhere. It needs to be put somewhere, y'all, in that, okay? You got to restate it. If you don't, you're going to get points counted off, and those are points that you really need. Yeah, this right over here is 100.73, which is my high value. And I'll do this other one just so we've got it here. 1.5 times 39.4, although I know it's going to be good. This is negative 56.87. So this would be low and high value, since all values fall between here, because the highest value is between 80 and 90. We conclude, or actually we know it's down here, right? It's 88.6. We conclude that there are no outliers on that. Okay? Good stuff. Okay, let's see here. We got over the bimodal. Lindsay, I'm coming to your question here because this is where I've stopped. Lindsay asks, okay, I'm sorry I have 3 brain cells, but like on the I got you, Lindsay. Don't worry. Okay, I thought you were being serious. I'm like, we're not talking about brain cells right now. But no, I hear what you're saying. It says a data set has a mean much larger than the median. Okay, stop right there. If that's true and they give that to you, let me back up. If they say that the mean is much larger than the median, okay, all right, there we are. And the answer is the distribution is skewed right, but isn't the mean usually closer to the tall if it's skewed? No. Remember, the mean is closer to the tail. Think of this. This is the lot of the data, right? But if this is a value on this outside, right out here, right? This value is going to pull the average towards it, right? The same holds true if it's the other skewed. Here's the big mound. Boom and boom. The mean is always pulled towards the tail because of the average. The median is just simply the 50th percentile or the halfway point, right? That's all that is. The mean is the actual average of it, right? I hope I make sense on that. Hoping I make sense. All right, cool. I'm hoping that's good. Lindsay, good. That's a good thought, Lindsay. Looking at it sideways. Oh, gotcha. Actually, that was still good to do. B on number 1, or on number, oh gosh, did I mess up again? Asked about B on number 1, not C. Okay, gotcha. Sorry, Lindsay. So let's look at B because that also is a good one. It says, give the 5-number summary. Explain why you see from these 5 numbers that the distribution is strongly skewed to the right. Very similar to what we just said, and this was really what a lot of people struggled on today. We see through these numbers whether it's skewed right or left based on the relationship between the mean and median. If the mean equals the median, or is pretty doggone close, we say it's approximately normal, right? Symmetric. But if the mean is greater than the median, in this case, here, let's write this out, 22.39. I'm going to just kind of draw this out, and I'm going to say this. Okay, so the mean is 22.39. That's the mean. And the median is lower, it's 12.66, okay? So this is the median. What would the graph look like? Well, we recognize that the 22.39 is over here. Remember, the mean follows the tail. So this is going to be the tail, right? And I'm not saying it's that bad, but you kind of get the idea, right? And the main hump is going to be where the median is, or the majority of the data, because that's where the 50th percentile is, right? The middle number. So because of that, how would I describe that? Again, context, I'm assuming you stated above. We could just say, because of the fact that the mean is much larger than the median, we can see that the tail of the distribution will pull the mean towards its direction. And because the mean is not resistant to outliers, but the median is. So the median would be closer to where the majority of the data is, where the mean would be follow the tail of where the distribution would be. That's really wordy, but along those lines of stating something that the median is not resistant to outliers, the median is resistant to outliers, but the mean is not resistant. The mean is affected by an outlier or data that is skewed. Cool? Very important concept, y'all. Very, very important. So if you're confused on that, let me know on that, okay? All right, you're getting some good questions in. I've got the 5-minute warning up and running. Do y'all have any last-minute questions? I may have missed one. I'm at the end of the questions right now, so if you've got any. Here's the deal. I see 11 of you have watched it, and I'm assuming that there's more that will watch it later on tonight. Some of you have come in and out on that. Here's the thing. Thank you for coming. Thank you, thank you, thank you. You are, man, it's appreciated. So I appreciate you doing that. 3 on other section of review. Okay. Eric, do you remember which one that would be? I just want to make sure that I'm good, that I can kind of see this here. 3 on other, because there's a couple, weren't there? There's a couple reviews. In fact, I think y'all's class made fun of me that I put too many resources up there. Just trying to help y'all. Just trying to help, you know. It's what we do on our AP Stats team. Let's see, let's scroll down here. Let's see. Yeah, and I'm just looking at this, making sure Eric's got that. Let's see. Yeah, Sydney, I'll do that. Gender means of transportation. Yeah, okay. Let's see this here. Is that the free response one? Is that a free response one? What was that again? Number 3. Okay, let's check this out. Sorry, I'm trying to get this one. Nope, that's not it. Yeah, I don't see that one. Eric, I might have you. Let me make sure this one. Is it? I might have you bring that into me tomorrow morning, possibly. I'm having a hard time locating it. On the other review, make sure I've got. Oh, is this it? Right here. Oh, is this it right here? Okay. Yeah, I'm going to put up the answers here. I think this one's it. Male and female. Is this it right here? Sorry, y'all. I'm trying to locate this one. Oh, the other section. I think you meant. I'm sorry, y'all. I'm going crazy. Two-way table with gender and means of transportation. Okay. When we look at this, I thought I had it up. Maybe I didn't. Sorry, I know that you're probably like, Coach Jay, seriously? Sorry about that. I thought I put it up here, though. I must not have. All right, well, we'll talk it through because I've got it, the answer sheet here. Number 3 states, discuss the relationship between gender and means of transportation to work for the working adults in the sample. Provide appropriate marginal and conditional to support your answer. You may choose whatever method you want to present these distributions. Well, you could do a side-by-side bar graph. You could also do a segmented bar graph. But the idea is, if you remember from the summer work, that you want to provide they first want the conditional. So we want the totals here. What percentage is male? What percentage is female? What percent drive alone? What percent carpool? What percent have public transportation? They've already pretty much, so that's what we would like to do. Now, these percentages that are on the inside represent the conditional distribution. For instance, this was 113 here, okay? And if that was 113, we take the 113 and we put it over the total of, gosh, how many total was that? I'm going to say like 400. But whatever it is, we've got to, that's way too much. I'm sorry. Whatever this number is, we divide it by, hold on. Let me rewrite this. I'm sorry, y'all. This is 85. This one is 16, 23, 6, and 7. I was messing up. I was mixing them up. So marginal would be taking the total and divide it by total males and dividing it by the total. And the same thing with female. We would also take the public transportation divided by the total, saying what percentage use public transportation. Same with carpool and same with driving alone. So that's marginal distribution. To find the conditional, which you see here, you'll total up the values. And what they're wanting here is they're trying to see specifically they want discuss the relationship between gender and means of transportation and the working adults in the sample, okay? So if you look at that, they're looking and saying, okay, we're trying to compare gender is what we're trying to do. We're trying to compare those that drive alone. For male driving, what percentage drive alone? What percent carpool? What percent public transportation? So we total this across 22 plus 113 would end up being 135. And we take 113 dividing by 135 to say 83.7% of males drive alone. And we then go ahead and compare that. Now, they also allowed you to do the two-way table, but you could also do a bar graph. You could do a segmented graph. I'd stay away from pie charts, but that's good there. And then just write something about it. So this one was one effective, and you're just comparing. One effective method for presenting data would be conditional distribution based on the gender. We saw that. Any response should discuss the moderate association between gender and means of transportation. Slightly higher proportion of females, carpool, if you wanted to say something along those lines. And use the numbers too. So when you use that, say that there's a higher percentage of males who drive alone than females based upon the data, that 83 point, then use this, okay? So those are big things there. All right, hey y'all, I could probably go all night. I know there's more questions here, and I'm gonna be in here at 7:30 tomorrow. Sydney, I see yours. Eric, I see yours. I'm going to do this, Sydney, on yours real quick because I did say I'd get to yours. Do I have a – okay, you see this is a histogram. Notice it's side by side because it's quantitative. What we're trying to do is we're saying the left side would be the number of states. This normally represents the frequency. And then also when we do this, remember the bottom side, that's context, okay? Make sure you put that. But as we go from 0 to 10, we're stating, if I had the list of data, right? List of data here, right? We're saying that between average annual tornado damage, that there are 23 states that spent between $0 and $10 million last year on tornado damage, okay? In 10 to 20 million, there were 5 states. So notice this is just step by step. So in a histogram, you're just totaling up the numbers that fall between whatever you decide to be your range. Sometimes it's very flexible on that, like it doesn't matter. Sometimes they give you the range and then you just have to fill it out. But regardless, you're just saying, Okay, between 0 and 10, this happened 23 times. Well, from 10 to 20, because it's quantitative, we connect it, making it a histogram, and then so on and so forth, okay? Sydney, if you need specifics, could we talk about that tomorrow morning? Because I know I think we're rocking now at close to an hour here, going on about an hour here. Let me address these last few questions. Emily says, what you may have already covered this, but when you make a stem plot, you only list the numbers that are in the data set. For example, if there aren't any 40s on a data set, you have to include the 4. Include the 4 so you see that it's blank, right? You see that there's nothing there, but just don't put anything to the right of it. So you see that there's an actual blank there. So like look at this. Notice they're 1 to 8. Make sure you leave that blank there. Great question. Ryan, why does it say give the 5-number summary if it's already there? Am I missing something? Great point, Ryan. I think that's a weird question. The 5-number summary, it's assumed that you know, but if you don't know, I would just list it out. Min, Q1, median, Q3, and max. So just make sure you list it out. Good question, though. It says skewed right. Is there a way you can tell which direction it's skewed from the data, or did it just give a side? I'm not sure, Lindsay. I'm not sure with the context there. Cool. Perfect. Eric, I know I went through those last few quick, y'all. If it was not good enough for you, I apologize for that. I know sometimes I'm a little limited by this, but then also time. I want to make sure that rest up for tomorrow because I'm going to be rearing and ready to go 7:30 tomorrow. Hey, so come on by if you do have any questions. Again, that's a very beneficial time as well. Hey, I love y'all. I care about y'all. Here you go. Hold on. I need to like look at y'all real quick. Is that cool? But hey, I really care about y'all. I love y'all. Here's the deal. Okay. I understand this first test. This is the first test for an AP stats test. It's different than any other AP. Okay. There's a learning curve. We are ahead of the game. Our class, I am extremely excited about, and I wouldn't just say that. Okay. With that being said, I just want you to do your very best, okay? So whatever you do, leave it out there and just understand this is a process. All of us are in this journey together. That's why we call it a team. But just know that I'm in your corner. I hope you felt that tonight. I hope you felt like I'm willing to do whatever it takes to be able to help you out with that. And so understand that and give yourself some grace because I appreciate the fact that you watched this and were a part of this. And so on your way out, hope you have a phenomenal day. And man, oh yeah, you know what I need? Hold on. Maybe this will get us going. Let me see. This is like my jam. You ready? This is my jam. You ready? Oh man, you gotta smile on this song. Little Earth, Wind, and Fire. Gotta love it. Hickey says bye. He's on his side. Have a phenomenal day. See you tomorrow. Bye.